Hello there and welcome to a brand new video. This is Hub Beyond Numbers where we learn maths the easy way. Now in this video we'll be looking at some word problems in relation to fractions. We'll try and understand how to solve word problems, how to get the equations from these word problems and then solve accordingly. So without much ado, let's quickly go into some of the questions we'll be looking at so we know how we can go about it. Okay, so if you look at our first question here, it says in a box containing red, blue, green, and yellow marbles, 1/4 are red, 1/3 are blue, and then 1/5 are green. What fraction of the marble are yellow? If there are 120 marbles in total, how many marbles are yellow? So let's look at how we go about it. So how do we go about this question? The first thing we need to do is quickly write out your parameters. You write out what has been given you from the question. So let's write that out. So this is the parameters we have, right? So we know the fraction for the reds are what? 1/4. That of blue is 1/3. That of green is 1/5. Whereas yellow is what? We don't know. Now the total marbles, the total number of marbles is 120. So let's quickly write that also out. So we have that now, right? So let's just say, since we are talking about fraction, then if we are adding the fraction of red to the fraction of blue to the fraction of green, and then that to yellow, they should give us the total what fraction of marbles we have. What that means is we add the fraction of red to the fraction of blue to the fraction of green, then also to the fraction of yellow. We are expected to get what? The total. And since we are talking of fraction, then the total will be 1. You see? So now let's do a substitution and then solve that out. So we have 1/4, which is red, plus 1/3, which is blue, plus green, which is 1/5, then plus yellow. Since we don't know yellow, let's just write yellow there. It's equal to 1. This here is what we do for addition of fraction. We do addition of fraction here. So we have 4, 3, and 5. What is their LCM? The LCM is what? So our LCM is 60. And if our LCM is 60, we ask ourselves, 4 divided by 60, how many times? 15. So 15 times 1, giving us our 15 here. Then 3 divides 60, 20. 20 plus times 1 gives us what? A 20. Then 5 divides 60, how many times? 12. 12 times 1 gives us a 12. Then plus that of yellow, which we don't know, is equal to 1. So adding all of this here, we have 15 plus 20, which is 35. 35 plus 12, which gives us 47. So 47 over 60 plus yellow is equal to 1. So at this stage now, we make what? Yellow the subject. We make yellow the subject. I think the full screen isn't showing, so let me just push this here a little. So we are making yellow the subject. Making yellow the subject, we have yellow is equal to 1 minus 47 over 60. Yellow is equal to 1 minus 47 over 60. This is also subtraction of what? Fractions. So let's copy that. Now in subtraction of fraction, so if you want to evaluate, we have our yellow or the fraction of yellow being equal to, we know this 1 here can be written as over 1. So the LCM then becomes 60. So 1 into 60, 60 times. 60 times 1 gives us 60. Then 60 into 60 ones. 1 times 47 gives us a 47. Then we now have 60 minus 47. 60 minus 47 gives us a 13. So our yellow now becomes what? 13 over 60. So this is the fraction that represents what? 13 over 60. Is there any way we can simplify 13 over 60? No. It is just as it is. So it simply means that from our question, from the question here, which says, what fraction of the marbles are yellow? It is 13 over 16 over 60. Now the question says, if there are 120 marbles, how many marbles are yellow? How many marbles are yellow? We are taking that also from what we have solved over here. We know that in terms of fraction, then the yellow marbles make up 113 over 60. That is in terms of fractions. The yellow marbles make up 13 over 60. So if you want the actual number, that is number of yellow, then we are going to multiply the fraction of yellow by the total number of marbles. And we know the fraction of yellow is what? 13 over 60. We are multiplying it by the total number of marbles. And from the question, that is 120. So times 120. This now is a simplification, a multiplication of fraction problem. All right. So how do we do that? If we want to multiply fraction, in our previous videos, we have said that try and simplify. This 0 here cancels out this 0. And 6 into itself once, 6 into 12 twice. So we have 13 times 2. 13 times 2 gives us a 26. So basically, this implies that the number of yellow marbles is equal to what? 26. Or there are 26 yellow marbles. So this is it for the first one. Let's quickly go into another example. So in this next question, it says, in a school, 7 over 8 of the students participate in at least one extracurricular activities. 3 over 5 of these students are boys. If there are 560 students in the school, how many girls participate in the extracurricular activities? This type of question can be translated into sets as well, but we wouldn't go into the set aspect. Let's solve it basically as fractions. So let's write down our parameters. So these are our parameters from the question. First of all, we know that the total number of students are 560. There are 560 students in the school. Secondly, 7 over 8 of the participants, or 7 over 8 of the total number of students participate in extracurricular activities. And also, of these people who participate in the extracurricular activities, 3 over 5 of them are boys. Now the question is asking that how many girls participate in extracurricular activities? How are we going to get to that? So first of all, we need the number of students, the number of students who participate in extracurricular activities. And how do we know that? Or how do we do that? We already know their fraction. Right? So since we know their fraction, all we need to do now is to multiply their fraction by the total number of students. What do I mean by that? So number of participants. So we want to solve for the number of participants. And we said the number of participants is what? 7 over 8 of the number of the total number of students. So that is what? 7 over 8 of. Of means times. So times the total number of students, which is 560. You see, so we now do our simplification. 7 over 8 times 560. We ask ourselves, 8 divides 560, how many times? And that is a 70. So doing our cancellation, we have 8 dividing itself once, and into 560, 70 times. They now come to 70 times 7. That gives us, so 7 times 7 alone gives us 49. So we have 40, 490. So the number of participants are actually what? 490. This means that the whole school, it is 490 students that participate in extracurricular activities. The next part says, of these participants, 3/5 are boys. Yes, they are boys. So let's calculate the number of boys as well. So number of boys. That is going to be 3/5 times the total number of participants. And we solved that to be what? 490. This here simply means if you solve the total number of participants and then you had it wrong, it is going to affect this one as well. You see? So 3/5 times 490 being our simplification. We know that our 5 divides itself once. And into 490, how many times? 98. Then 98 times 3 gives us 294. So we have 294 over here. So this out of the participants, it is 294 that are boys. But our question says, how many girls? And we know if you are not a boy, you are a girl, right? It's either boy or girl. So if this number here represents the total participants, and out of that number, we have 294 being boys, then the girls will be very, very simple. So we come to number of girls. So the number of girls, which is the main part of the question, it is going to be 490. That is the total number of participants minus 294. 490 minus 294. And if you have to solve it, that gives us 196. So we say, therefore, what is the question says? How many girls participating? So therefore, 196 girls participate in what? In extracurricular activities. In extracurricular activities. As simple as that. So this is our second question. We'll solve one last question, after which I'll post or put down some questions you can try on your own as usual. Let's look at our next question. So in this last question here, it says a tank was 4/5 full. After 150 liters of water were used, the tank was only 2/5 full. The first one says, what is the total capacity of the tank? And then the second one says, how much water is needed to fill the tank completely from its current level? Now we are going to use two methods to solve it. The first one, we are just going to apply the meaning of fraction we have learned so far. And then the second one, we'll use ratio and then proportion, proportion to solve it out. So for the first one, when we say 4/5, what does it mean? When we say 4/5, it simply means you have a quantity of something and you have divided it into how many equal parts? Into 5 equal parts. You have a quantity of something and you have divided it into 5 equal parts. So I'm going to draw a representation of the tank here so we see. So this here is going to be my tank. You see, this here is going to be my tank. And I'm going to divide it into 5 equal parts. So this is my first portion. Let me use a white. This here is going to be my second portion, my third portion, my fourth, and then fifth portion. So 1, 2, 3, 4, 5. This is actually a tank I have drawn here. Now, a tank is 4/5 full. 4/5 full. So this is 1/5. This is 2/5, 3/5, 4/5. So the tank is full, or it has been filled up to this side here. That is the 4 over 5. So let's fill this tank with water. Remember, it's just 4 over 5. So this here is going to be my 4 over 5. This is the 4 over 5 filled tank. You understand? So this is my 4 over 5. Let's indicate that here. From here to here is a 4 over 5. Or the tank is 4 over 5 full, right? So this is the 4 over 5 we have actually filled. Now the next part of the question is saying, after 150 liters of water were used, after 150 were used, the tank was only 2 over 5 full. This is 1 over 5, 2 over 5, 3 over 5, 4, 5 over 5. So after someone came to fetch some of the water, we just had 2 over 5 full. So let's represent the remaining water and then we see. So for the remaining water, this is going to be our remaining water. This here is our 2 over 5. 2 over 5. And this 2 over 5 is that after 150 liters of water were used. So it means that this portion here that has been used is also 150 liters. 150 what? Liters. Let me minimize that so I can write for us to see clearly. So we are saying this portion here that has been filled is 150 liters. So let's try and then go over again to get the understand. First of all, a tank is 4 over 5 full. Now it means we have the tank and we have divided it into 5 equal portions, of which 4, just 4 portions is full. So 1, 2, 3 for the initial full white. That is what we are using this curly brackets to represent. Now out of this 4 over 5, 150 liters of water has been what used. 150 liters of water has been used. And now we are just left with 2 over 5. That is the blue part here, 2 over 5. If this part is 2 over 5 and then this 2 part is the 150 liters, this would be our drawing. Now the question says, what is the total capacity of the tank? What is the total capacity of the tank? How do we get a total capacity? We know it has been divided into 5 equal parts. And 2 of the parts, let's say 1, 2, represent what? 150 liter. You see? So if these 2 parts represent 150 liter, we can get how many 1 part represents. And I guess you can do that. So if 2 parts represent 150, then 1 part will be what? 150 all over 2. And 150 all over 2 gives us what? 75 liters. So it means that each portion, so let's do that representation here so we see. Each portion, which I'm going to shade with different colors. So let's start with a green and then make it deep. So for this portion here is going to be what? 75 liters. Followed by our next portion, which is this one here. That is also going to be another 75 liters. Then on and on and on. This portion as well is going to be 75 liters. This one here. This is also 75 liters. Then our next one is also going to be 75 liters as well. So this here will be our 75 liters. And then the last one is also 75 liters. That is why this 75 plus this 75 give us what? The 50 we have over here. So if each portion is 75 liters, what is the total capacity? The total capacity, we are just going to multiply 75 by what? 1, 2, 3, 4, 5. Because there are 5 portions. This here included. You see? So let's quickly solve that. So our A, total capacity, is going to be equal to what? The 75 liters times 5. Right? And 75 liters times 5 gives us a what? 375 liters. So in total, the tank is what? 375 liters. Now the next part of the question says, how much water is needed to fill the tank completely from its current level? What is the current level of the tank? This and then this are the current level of the tank. This one here. Easy. This here is the current level of the tank. And what is its capacity? It is just made up of two portions, you see. And we have said that one portion is 75 liters. So this here is 75 plus 75, giving us 150. So it means the current portion of the current level of the tank is 150. So we know that the current level is equal to what? 150 liters. And we know the total is what? Is 375 liters. So the needed, how much water is needed is going to be what? The total, which is 375, minus the current level, which is 150. Subtracting that, we have 375 minus 150, and that gives us a 225 liters. So this here is what? The total, or how much water is needed to fill the tank. So this is the first way we can solve it using the knowledge of fractions we have studied so far. Let's try and use ratio and proportion and see how that is also going to benefit us. And if you want that one or you prefer that one, you can stick to that one as well. You know, there are so many ways of solving maths. The most important thing is you understand what you are doing, and then you can easily flow with it. The tank was what? 4/5 full. After 150 liters of water were used, the tank was only 2/5 full. What is the total capacity of the tank? What is the word total capacity of the tank? So first of all, let's write down our parameters. So any method you want to use, you still need to write out your parameters. So let's quickly write out those parameters. So this here is our parameters that we have from the question. The tank was 4/5 full and then 150 liters were used. 2/5 is now left. So if you want to use a ratio and proportion, the first thing you need is what? How much fraction does this 105 liters that has been used represent? And how do we get that? We are going to use the fraction of the tank that is full minus that which is left, 2/5. As you can see, this is clearly like fractions. So 4 minus 2 gives us a 2, then all over 5. So this here is the fraction that was used. You see, this we have here is the fraction that was used. That is this over here, the fraction that was used. Okay, now that we know the fraction that was used, using ratio and proportion, we'll say that if 2 2/5 is equal to 150 liters, you see, the total capacity will be what? 1. The total capacity is going to be 1. So 1 will be equal to what? And it will definitely be more. We say if more, less divide. So that is, we have 1 divided by 2/5, after which we multiply by 150. If you have not done ratio and proportion and you don't understand this, it's fine. But if you have done it, I think you can be able to relate to this. So solving our fraction, we have 1 times 5/2, then times 150. 1 times 1 times 5/2 gives us a 5/2. Then we say times what? 150. Now we know 150 divided by 2 gives us a 75. So 2 divides itself once into 150 how many times? 75. Then we now multiply our 75 by 5. And that should give us 375 liters. So it means the whole tank when full, or the total capacity of the tank is what? 375. Just as we solved in the previous one. I'm going to skip to that one so we see. So this is what we did for the previous one. Total capacity 375. Any of the method work, and then it's up to you to choose. Now the next one says, how much water is needed to fill the tank completely from its current level? What is the current level of the tank? We were told that the tank was just 2/5 full. From the previous solution, or from our initial one, we have realized that. So we know this from the initial part of the question. All right. Now, how much water is needed to fill the tank completely from its current level? This is its current level. You see? So to get the remaining that we need to make it full, then the B part is going to be what? Its total when full. That is 375 liters minus its current level, which is 150 liters. Right? So solving for that is going to give us 225 liters. And as you can see, that is no different from the initial method we used to solve. Right? So they are all similar. So any of them you would wish to use, if you understand fractions and you want to solely rely on fractions, fine. Here's a nice diagram you can use. If you have done ratio and proportion also and you think this is fine, they are all good to go. So I'll be posting some questions in the try section. You can try on your own. So these are some try questions you can try on your own. The first one, you can do it as homework. Then the second one, you can try in class. Stay blessed. Now, in our next video, we'll just be solving. We are basically done with everything under fractions. And we'll be solving some likely examination questions and some BC past questions. So we know how to approach these questions when we meet them in exams. These are beyond numbers, and I do hope you have learned something new in this playlist. If there's anything you think I haven't covered under fractions that you think you would want to know, you can let me know at the comment section and then I will address that for you. So until then, we are done with fractions and we'll just be solving examination questions. Some would have been based on your request. So if you have any question you want me to go through, you can let me know in my contact on Telegram or send me a mail, or you can just post it on the comment section. And if perhaps I see it, I'll address them for you. Until then, stay safe and then stay blessed.